Okay, so we're going to talk about graphing tangent, secant, cotangent, and cosecant right now. So the first thing that we want to talk about is, and note, that cosecant and secant are just reciprocals of the sine functions and the cosine functions. Now reciprocal means 1 over. So because they're reciprocals, that means they'll have the same period. Now sine and cosine both have a period of 2 pi, therefore secant and cosecant will also have a period of 2 pi. So, because of that, we can say cosecant of x plus 2 pi is the same thing as cosecant x. We can also say secant of x plus 2 pi equals secant x. This just says that cosecant repeats every 2 pi and secant repeats every 2 pi. Okay? Now, tangent and cotangent are a little bit different. Both tangent and cotangent have a period of pi, so it's a little bit different. So over here we're going to have tangent of x plus pi equals tan x, and cotangent of x plus pi equals cotangent x. Okay? Okay, so now we're going to talk about graphing tangent. Okay, graphing tangent. Well, tangent has a period of pi. Okay, so we know that if we get one of the periods, we can just copy and paste that multiple times over to get what the graph of tangent will look like. Another thing to note is that tangent x is equal to sine over cosine. Now, in any fraction, anytime you have a denominator, the denominator can't equal 0. So what values of x make this denominator equal 0? Well, you note that if we have the unit circle, at this point right here, that's the point 0, 1, okay? And this is some t value. Find this to be our t value. This t value from here to here, that's t equals pi over 2. So if I wanted to find tangent of pi over 2, I could do that by simply doing sine of pi over 2 divided by cosine of pi over 2. However, if cosine x, or cosine of a value t, is equal to the x-coordinate, what's the x-coordinate here? 0. So this would be 1 divided by 0. This is undefined. So we know that tangent x is undefined at pi over 2, but it's also undefined at t equals negative pi over 2, because again the denominator would be 0, because this terminal point is the point 0, negative 1. So we know that our function tangent is not defined at pi over 2 or negative pi over 2. Now what does that do to us? Well, what that does is that creates what we call vertical asymptotes at those two values. So here's pi over 2, and here's negative pi over 2. And what we get is we get these asymptotes. Now what's an asymptote? A vertical asymptote is in a pretend little line here that your function is going to approach but never actually get to. So it's going to approach and get closer and closer and closer. It's never actually going to get there. Okay? So, if we started creating a table of values, the first thing that we'd note is, what's tangent of 0? Well, that's sine of 0 divided by cosine of 0. Well, here's the point 1, 0, right? That's for a value of t equal to 0. So sine of 0, okay, when t equals 0, this terminal point equals 0, sine of 0 is the y-coordinate, okay, so which is equal to 0, divided by cosine of that t value 0 is 1, okay, so 0 over 1 is 0. So we know that tangent but has a point right here. And then as we approach, so what's going to happen is as you approach pi over 2, so as this function gets closer to pi over 2, it's going to get a denominator that's closer and closer to 0. But it's also going to be a positive number. So it's a very small positive number. When you divide by small, you get big. Think about it. If I had 1,000,000, divide it by 2, I get less. But if I divide 1,000,000 by 1/2, I get 2,000,000. Next you get bigger. And you divide 1,000,000 by 1/10, you get 10,000,000. You get bigger. The smaller you divide a number by, like as a fraction, the bigger it gets. So if I divide by a positive small number, what's going to happen is this function is going to explode and get really, really big. Okay? Really, really big. And on the other side, it's actually going to get really big negatively. Okay? Because we're going to be dividing by small still. Right? We're going to be approaching 0, but we'll be approaching 0 negatively. Okay? So what we'll have is we'll have a negative value divided by a positive small. Okay? So what that does is this gives us our tangent function over that period of pi. Now, of course, once you get one period, you can do all the others. So we know that this function also, another period of pi would be over here, say, at negative 3 pi over 2. If I extended this axis out, and I'd get the exact same look of this right here, and there'd be another asymptote approximately here. So we copy and paste, and copy and paste over and over, and that's the graph of tangent. Okay, so we graphed tangent x. Okay, here's tangent x. I've drawn a couple periods of it. What we want to do now is graph cotangent x. So what is cotangent? Cotangent is just the reciprocal of tangent. So if you know how to graph tangent, well, cotangent is just the reciprocal of it. So the outputs of tangent, you just do 1 over the outputs. Okay? So if an output of 1 is 2, you just graph 1/2 as the same output given the same input. Okay? So what do I mean with that? I'm talking a lot of stuff. What the heck do I mean? Alright, so let's talk about this. Right here's a point on tangent, 0, 0. Okay? 0, 0 is a point on tangent. Okay? Alright. So we know that tangent of 0 yields 0. Okay? What about cotangent of 0? Okay? Well, that's 1 over tangent 0. But what's tangent 0 equal to? Tangent 0 is equal to 0, right? What's 1 over, because cotangent x is equal to 1 over tan x, but if tangent of 0 is 0, we'll have 1 over 0. That's undefined. You can't divide by 0. What that says is, instead of having asymptotes like cotangent, or that tangent does right here, cotangent is going to have an asymptote right here. This is the output here, the height is 0. 1 over 0 is undefined. 1 over the output tan 0 is undefined. Similarly, at this point, 1 over 0 is undefined. So we've now got asymptotes here at 0 and pi and 2 pi and so forth for the cotangent function. Okay? For the cotangent function. Now, so we know that cotangent's period is in here, right? We repeat it in here, we copy and paste it. So let's find out what's going on in here. Well, we know that tangent is undefined right here because we're dividing by 0. Okay? Whereas we have 1 divided by 0. Okay? Can you divide by 0? No. But if I have 1 over tangent of pi over 2, now tangent of pi over 2 is undefined, but if I have 1 over that value, I'll end up getting 0. Okay? Because now 0 is in my numerator, because it's 1 over rather than in my denominator. And if we look at the outputs of this, these are all positive outputs, okay, that get closer to 0. Remember, if we divide by 0, we get something that's very large. So we're going to have this. 1 over small is large. And then over here, we're going to 0 here. Blue is 0 right here. So we're going to get negatively large. So the graph of cotangent looks something like this. And then we copy and paste it like that. So if I erase the blue now, we have the graph of cotangent x in green. Okay, so cotangent x again has period pi. We copy and paste it. Okay, it's the reciprocal function of tangent, and there we are. Okay, now we're going to graph cosecant x. Okay, cosecant x. So we want to graph cosecant x. Y equals cosecant x. Same type of process. It's a reciprocal function. Cosecant is just 1 over sine. So if it's 1 over sine, it's 1 over the outputs of sine. So what are the outputs of sine? Well, what's the output here, right here? The output, the height. That's what I mean by outputs. Outputs are heights. What's the height right here? Well, that height is 1. What's 1 over 1? The output of sine, the height of sine, is 1. Therefore, the output, the height of cosecant, is 1 over sine, 1 over 1. So my output will be right there. What's the output right here for sine in blue? The output, the height is 0. What's 1 over 0? Again, 1 over 0 isn't defined, but it's a large number. It's very large because we're actually not getting to 0. We're getting really close to 0. So we'll have this vertical asymptote again, and it's positive, so we're going to approach it. Okay. Output for sine is 0. 1 over something close to 0. Okay, it is positive, approaches infinity. So we say we're going to approach this vertical asymptote this way. All right, good. What's the output of sine right here? Well, it's -1. What's 1 over -1? Well, it's -1. Okay, so what's going to happen here? Well, again, we get to 0, but it's a negative, like a negative small fraction. 1 over a negative small fraction is very large. So we're going to approach it here. And similarly, we've got another vertical asymptote. So we're going to have that situation. So what does cosecant look like in an interval of 0 to pi? We've got these reciprocal functions here, here. This is the 0 to 2 pi. So if I want it from 2 pi to 4 pi, I copy and paste, right? Same thing over and over again. If I want it from -2 pi to 0, same thing right here. So if I erase what's in blue, okay, we now have the graph of cosecant x.